Hello everyone and welcome to this new video tutorial. Today in this video tutorial I am going to teach you that how to simulate concrete cylinder in ABAQUS. So this is very simple and this is completely just in a few steps. You can see the model and these are the mice stresses in the model, and let's say the compressive damage of the model. This is the compressive damage of the model. Now, at the end of this video tutorial, you will be able to create this type of cylinder and simulate it in ABAQUS, and also you will be able to provide compressive stress strain data from the results. There are different modules in ABAQUS, like part module, property module, assembly module. So this each module will be followed step by step. So first of all, I would like to start from part module. In part module, we simply create the cylinder, concrete cylinder. So we can create steel plates to put above the cylinder. If you are not interested in that, so you can avoid. So simply to create the part of this model, so you will like to click on create part. Now rename the part module part. So simply then click continue, and then simply click on circle. You want to draw the dimensions of the cylinder, so let's start the center from centroid and just roughly draw a circle. Let's click here and then click on dimension. So add dimensions, so click here, and now the radius of this circle is 36. So I would like to put it 75 because the diameter of the cylinder is 150 mm, so this is 75 mm. So press enter. Now the cylinder section is down, and then simply finish this command and then click on done. So now the height of the cylinder is 300 millimeter, so type 300 millimeter and press ok. Now this is the cylinder is down. After that, you would like to create some datum planes. So first of all, we would like to create some partitions in this cylinder. The partitions are very important because when if we come to mesh, so if I mesh this model, so this will not mesh properly. So for to avoid it, like, you can see this mesh. So this is not a correct mesh. So we would like to divide it in different partitions. So first of all, we would like to create datum planes, and then we will create partition from that datum planes. Let's suppose I would like to click on this offset from a plane, so I would like to select this front plane and then enter the value, click on it, and then flip to inside the model. So okay, and now I would like to put 150 to datum plane will become at the center of this. You can see this red yellow datum plane, and after that I would like to click here and select 3 points to create datum plane by 3 points. So first of all, I would like to click this first point and then second point, and this is a third point, and then the datum plane is created. And after that, I would like to create partition of this. So partition does not mean that to divide it in actually in two parts. It means that to divide the structure in for meshing purpose, that will be easy to mesh. So now I would like to click here, and there is also different options. Partition cell, define the cutting plane, and partition cell, use datum plane. So I would like to select this to select datum plane. So after that, I would like to click on this datum plane and create partition. Now you can see now the cylinder is divided in two parts. So after that, I would like to again select the model and done. And now select this datum plane to divide it here at the center, and again I would like to create 3 points another to divide it to create one another datum plane. So I selected these 3 points, and now the datum plane is created here. So after that, I would like to select on the partition cell. So now I would like to select this cylinder and press ok, done, and then select this datum plane too. to create partition. So simply click it. Now you can see this model is part divided into different parts. So this is the purpose of this was to mesh easily the model. Now you can see the model can be easily meshed. Let's specify the mesh 10 mm. So simply put 10 mm and then apply in OK. After that, click on mesh part and then click on yes. Now you can see the model is meshed correctly. I provided the mesh 5 mm. You should provide accordingly. So after that, I would like to come to create property. Property module is used to create and assign the material to the model. So I have already created the material, that is concrete 40 MP concrete. So you can see the properties. This is the density of the material. The elastic properties is provided, and concrete damage plasticity. This is also provided. You can provide this from let's suppose density. We can in general, and then we click on density, then provide the density value. And also the mechanical elastic properties, you can see elastic, then simply click on elastic and then provide the Young's modulus and Poisson's ratio. This is provided here, and after that you can see the concrete damage plasticity. This is also here in mechanical, and then simply come to plasticity and then concrete damage plasticity. You can see this option and simply click on it, and then provide this specification. Dilation angle is 40-degree, eccentricity and K values all are provided here, and also the compressive behavior, compressive yield stress and inelastic strain is also provided, and their tensile behavior is provided, and also compressive damage data is provided here, and tensile damage data is also provided here. So I provided the link of this data. You can download from description. So simply create these properties, and after that you would like to create the section, simply click here on the create section. Now we should rename this section like a concrete section, and then simply click on continue, and then select that material. Let's suppose concrete CDP 40 MP. So simply press OK. After that, simply click on this assign section. So simply click on it and then select the model, complete model, and then click on done, and then select that created section, let's suppose concrete section, and then simply OK. Now you can see the color is changed, and this means that the materials assigned. After that, simply come to assembly. So click here and click on assembly, and now click on this instance, create instance. So simply click on it, and now select the cylinder and then OK. Now you can see cylinder. So after that, I would like to rotate it. So simply click on this rotate instance, and then this is single part and single element, so there is no need of selection. So simply specify the axis, on which axis you want to rotate it. So let's rotate it on x-axis. So the degree of rotation is 90 degrees. So simply press enter. So now I would like to click on done, that the model is rotated, and after that I would like to move it. So simply click on translate the instance and then specify the base point. So let's suppose this is the base point, the center of this cylinder, and now I would like to move it to the center of uh, coordinate system XYZ. So simply press enter, that the values are already 0 0. So now you can see it is moved. So simply click on done, and now you can see this is at the center of the coordinate system. After that, simply come to tools and click on reference point, and simply click at the center of this cylinder, and this is reference point 1. And then come to tools and click on sheet, and is click on manager and create one sheet. Let's suppose create our reference point like RP2. So simply continue and then select this reference point and click done. So this is created reference point sheet, and after that you would like to come to steps. So per step, simply click on create step. So in this case you can create static general, but we would like to, we prefer dynamic explicit. in this case. So simply click on dynamic explicit and click OK, and then simply select this by default. So mask scaling, if you want to add, you can include mask scaling to reduce the computational time of your analysis. So simply click here and then click on create, and let's suppose specify the scaling factor like 1000 and press OK, and then OK. The strip is created, and then field output, simply click here and then click on edit. So in field output, we do need contacts, simply failures. In failures, we need compressive damages, tensile damages, and then simply status of the failure. So we would like to also click here status and then OK simply, and then again come to ST output and click on edit. So we don't know energy, so we would like to click here and select a sheet. So select the reference point to which we have already created a sheet. For that sheet we need to uh, force and displacement. So the load will be applied in second direction, so you would like to select U2 and IPR RF2. So select RF2 and press OK. So again dismiss it. One thing you should note in field output, that is increment to increase increment. Is for that simply click on every increment, every x unit of time. So let's suppose the time was 1 second, so we would like to put here 0.01 second uh, frequency to increase increment. If we do not put this the analysis will complete just in a single increment. And after that we would like to come to interaction module. So simply come to interaction module. In the interaction module there is no proper interaction. Simply one is coupling, so we would like to click on constraint. Here you can see this constraint and click on it, and then simply select the coupling and then continue, and then specific select the reference point and then done, and then specify the surface, and this surface will be coupled to this reference point 1. Sorry. If you want to select multiple areas, so you would like to hold shift and then click on that area. That will be multiple for multiple selections. So simply click done and then OK. Now you can see this area is coupled to this reference point 1. After that, come to load module. Simply click here and click on load module, and then specify the boundary condition. The bottom of the cylinder is fixed. So simply click here and create boundary condition, and then select the this first option, and the step should be initial, and then click continue and select this area. The bottom of the cylinder will be fixed. So simply select this area and then done. So select the last option. This is fixed. So now you can see the bottom of the model is fixed, and then after that we will apply the displacement load. So simply click here and then select the displacement, and then select the strip for the first strip. So simply select first strip and rename it. So then continue it and then select the reference point 1 and click on done. Now all the values would be 0 except on y-axis the load will be applied axially, so vertically, so the displacement will be minus 3 mm. So simply select 3 mm, and then the amplitude would be uh, ramp, or you would select your own amplitude. So simply click on this and then continue. Now we can see the load is applied. Amplitude is very simple, that is you can see here, you can see amplitude here, amplitude 1. So simply edit it. Now you can see this is 0.1. Gradually the displacement is increased with time frequency. So this is the load amplitude. So simply OK. After that we would like to select come to mesh module. You can see the model is already been meshed. So now we would like to come to job, and simply click here the list of the job, and then create job. This is name the job and then continue, and then select the according to your processor your core. So I would like to select here 6. So then click OK and then submit the job. Now we can see the job has been submitted. Let's monitor it, and now we can see the job is successfully submitted and there is no error. So this will take time. So after completing the job I will show the results, and now we can see the biggest explicit packages as it is completed. And now you can see the job is successfully completed, and let's see the results. So for that select the job and then click on results. Now we can see the model, and these are the results. So let's say compressive image of the model. This is compressive image of the model, and this is the animation of the period. Thank you for watching and stay blessed. Allah Hafiz.